Welcome to today's lesson, which is about solving real-world problems using algebraic equations. The goals of today's lesson are that given a verbal description of a problem, you can draw a model to represent the situation, you can write an equation to represent it, you can solve the equation, and you can check that your solution makes sense. So here we have an example where a homeowner is building a rectangular fenced-in dog run with 250 feet of fencing materials. She wants the length of the dog run to be 20 feet greater than the width, and she wants to use up all of her fencing materials. So we're asked to write an equation and use it to determine what the dimensions of her dog run should be. So the first thing I will do is I will draw a model to represent this situation. It's a rectangular dog run, so I'm going to draw a rectangle. And this is the width, and these are the two lengths. And she's going to fence it in, so the fencing is going to go all around the outside edge of the dog run, and all around the outside edge of any shape is the perimeter. So here in this case that's the fencing. So the fencing is going to go around the perimeter, and we calculate perimeter by adding both of the lengths and both of the widths. Now something else we know is that the length is the width plus 20 feet. It's 20 feet more than the width. So length is equal to width plus 20. I'm going to write there. Plus 20. So I can replace the L's in my equation. 2 times, instead of L, I can have width plus 20. And then I have the 2 width as well. And instead of just writing perimeter, I'm going to write 240 because we're told that there's 240 feet of fencing altogether. So now I have an equation I can work with. I have all my variables are W's and I have my numbers, so I'm just going to solve this equation. And first I need to distribute this 2 over W and 20. So 240 is equal to 2 times W, and 2 times 20 is 40, and I have another 2W for the 2 width. So I just want to write a little note here for you. This is my 2 lengths, and these are my 2 widths. So now next I'm going to combine like terms. 2 width and 2 width is 4 width plus 40. So now I want to isolate my terms with variables on one side of the equation and my constants, my terms without variables, on the other side. So I'm going to subtract the 40 from here, and I got to do it on both sides. So now I get 4 width is equal to 200, and I'm going to divide both sides by 4, and I get width equals 50. So my width is 50, and 50 what? Let's go back and look at the problem. 50 feet. And this is 50 feet here as well. And we're told, or we've figured out, that the length is the width plus 20. So it's 50 plus 20, which is 70 feet. And 70 feet here as well. So we have our dimensions, 70 feet by 50 feet. And now we should check and see, does this make sense? So I'm going to check here. If I add all 4 sides, do they add up to 240? And so I have 2 times 50 for the 2 width and 2 times 70 for the 2 lengths. Does this add up to 240? So 2 times 50 is 100. 2 times 70 is 140. 100 and 140, yes, it's equal to 240. So yes, I am happy with my answer. So you saw here I drew a rectangle and filled in variables around it, L and W. I wrote my formula, perimeter is 2 length and 2 width. I filled in the numbers I had as I got them, and I made notes in my work as I worked so I could come back and check it, and so it would make sense to me. And then I checked my answer at the end. So it's really helpful to draw a model. There I drew a rectangle. You could draw a number line. You could put your numbers in a table or draw a bar model to display the information you're given and to help you make sense of the problem. And when you write an equation, does it match the information in your model? And when you solve the equation, compare your solution with your model. You saw that I went back and checked if my numbers all added up to 240. So today you saw how to draw a model to represent the situation, how to write an equation, how to solve it, and how to check that your solution makes sense. And that's the end of today's lesson.